Hello students! In this video lesson, we're going to discuss about the K-12 mathematics curriculum in the Philippines. Here are our lesson objectives. At the end of the lesson, the pre-service teachers should be able to define the twin goals of the mathematics education in the Philippines, discuss the conceptual framework, identify the 5 content areas in the mathematics curriculum, specific skills and processes to be developed by learners, values and attitudes to be honed, mathematical tools to be used, the context of mathematical education, and the supporting learning principles and theories, and determine the learning area standard and key stage standards for primary mathematics education. Students today require stronger mathematical knowledge, skills, and values to pursue higher education, to compete and be part of the technologically oriented workforce, and to be informed citizens. They must gain an understanding of the fundamental ideas of numbers and number concepts, measurement, geometry, probability, data analysis, patterns, functions, and algebra. They must be proficient in computing, problem solving, representing ideas and concepts, and in connecting mathematics to other areas in life. Students must also learn to use a variety of methods and tools to compute, including paper and pencil, mental arithmetic, estimation, calculators, and computers. The use of technology and other hands-on tools must be an integral part of learning mathematics. However, technology alone shall not be regarded as a substitute for all pedagogies, particularly if these have been proven effective in developing students' mathematical understanding, proficiency in solving and computing. Here is the conceptual framework of mathematics education in the Philippines as presented by the Department of Education. Notice that at the center of this framework are the 2 most important terms, namely critical thinking and problem solving. Around these terms are the principles and theories of learning, namely discovery and inquiry-based learning, experiential and situated learning, reflective learning, constructivism, and cooperative learning. Also, notice in this framework that at the different corners of the given star are the different terms like content, skills and processes, values and attitudes, mathematical tools, as well as context, each of them having different descriptions under their umbrella. Specifically, under content, we have numbers in number sense, measurement, geometry, patterns in algebra, as well as statistics and probability. Critical thinking and problem solving as the twin goal of Philippine mathematics education. Critical thinking, according to Scriven and Paul, is the intellectually disciplined process of actively and skillfully conceptualizing, applying, analyzing, synthesizing, and or evaluating information gathered from or generated by observation, experience, reflection, reasoning, or communication as a guide to belief and action. On the other hand, mathematical problem, according to Polya, is finding a way around a difficulty, around an obstacle, and defining a solution to a problem that is unknown. These 2 goals are to be achieved with an organized and rigorous curriculum content, a well-defined set of high-level skills and processes, desirable values and attitudes, and appropriate tools taking into account the different contexts of Filipino learners. The 5 content areas in the curriculum. There are actually 5 content areas in mathematics curriculum. We have numbers and number sense, measurement, geometry, patterns and algebra, as well as probability and statistics. Under numbers and number sense are the topics: concept of numbers, properties, operations, estimation, and their applications. Also, under measurement are the different topics which include the use of numbers and measures to describe, understand, and compare mathematical and concrete objects. Measurement focuses on attributes such as length, mass and weight, capacity, time, money, and temperature, as well as applications involving perimeter, area, surface area, volume, and angle measure. More so, geometry is a topic which includes properties of 2- and 3-dimensional figures and their relationships, spatial visualization, reasoning, and geometric modeling of proofs. Moreover, patterns in algebra includes patterns, relationships, and changes among shapes and quantities. It includes the use of algebraic notations and symbols, equations, and most importantly, functions to represent and analyze relationships. Lastly, statistics and probability involves developing skills in collecting and organizing data using charts, tables, and graphs, understanding, analyzing, and interpreting data, dealing with uncertainty, and making predictions about outcomes. The specific skills and processes to be developed. There are different skills and processes that are needed to be developed among young learners. Specifically, we do have knowing and understanding, estimating, computing and solving, visualizing and modeling, representing and communicating, conjecturing, reasoning, proving and decision making, applying and connecting. Mathematics curriculum, specifically in primary education, there are different values and attitudes that are needed to be honed. These values and attitudes include accuracy, creativity, objectivity, perseverance, productivity. The mathematical tools to be used. So there are different mathematical tools that we can use in this specific framework. We have manipulative objects, measuring devices, calculators and computers, smartphones and tablet PCs, as well as internet. The context of mathematical education. Context is defined as the locale, situation, or set of conditions of Filipino learners that may influence their study and use of mathematics to develop critical thinking and problem-solving skills. Now, what are the different contexts that we need to consider in educating our children, specifically in the primary grades? The different contexts are the beliefs, the environment, the language, The culture, which includes their traditions and practices, as well as learners' prior knowledge and experiences. Supporting learning principles and theories. There are different supporting learning principles and theories that we can actually apply in order for us to become effective educators of mathematics in Philippines, especially in primary grades. We have experiential and situated learning, reflective learning, constructivism, cooperative learning, as well as discovery and inquiry-based learning. So, what are these learning principles and theories, and what are the different situations that we can actually use them in order for us to teach effectively in our classes? Let us first discuss experiential and situated learning. Experiential learning, as advocated by David Kolb, is learning that occurs by making sense of direct everyday experiences. Experiential learning theory defines learning as the process whereby knowledge is created through the transformation of experience. Knowledge results from the combination of grasping and transforming experience. So in short, in order for us to effectively teach mathematics into our primary learners, we needed to relate our mathematics lessons into their everyday experiences so that they can understand and appreciate our lesson in class. On the other hand, situated learning, theorized by Lev and Wenger, is learning in the same context in which concepts and theories are applied. So in short, in order for us to effectively teach mathematics in our classrooms, in our classes, we needed to provide the pupils or the students with the experiences that would lead them to apply the concepts and theories in the same way that it is being applied in a real-life situation. So in such sense, simulation or the actual thing or the actual experience or the actual applications will be very helpful in order for them to really understand and grasp our lesson in mathematics. Next is reflective learning. Reflective learning refers to learning that is facilitated by reflective thinking. It is not enough that learners encounter real-life situations. Deeper learning occurs when learners are able to think about their experiences and process these, allowing them the opportunity to make sense of and derive meaning from their experiences. So what is our role as teachers then? We as teachers and as facilitators of learning should have to devise some strategies and approaches or learning experiences so that we can lead the students or the pupils to think about their experiences and reflect off of these experiences so that they can learn our lessons well. Next is constructivism. Constructivism is the theory that argues that knowledge is constructed when the learner is able to draw ideas from his or her own experiences and connect them to new ideas. In short, the student has the ability or the learner has the ability to construct ideas out of his or her experiences. Our role then as facilitators of learning is to make them realize give them experiences for them to construct meaning out of the things that they have experiences or connect ideas to our lessons in our classes. Cooperative learning. Cooperative learning puts premium on active learning achieved by working with fellow learners as they all engage in a shared task. The mathematics curriculum allows for students to learn by asking relevant questions and discovering new ideas. The last one is discovery and inquiry-based learning. Discovery learning and inquiry-based learning support the idea that students learn when they make use of personal experiences to discover facts, relationships, and concepts. Learning area standard and key stage standards. Learning Area Standard. The learner demonstrates understanding and appreciation of key concepts and principles of mathematics as applied using appropriate technology in problem solving, critical thinking, communicating, reasoning, making connections, representations, and decisions in real life. In primary education, here are the key standards for K to 3, or from kindergarten to grade 3. At the end of grade 3, the learner demonstrates understanding and appreciation of key concepts and skills involving, under numbers and number sense, we have whole numbers up to 10,000 and 4 fundamental operations including money, ordinal numbers up to 100, basic concepts of fractions. Under measurement, time, length, mass, capacity, area of square, and rectangle. Under geometry, 2-dimensional and 3-dimensional objects, lines, symmetry, and tessellation. Under patterns and algebra, continuous and repeating patterns and number sentences. And under statistics and probability, data collection and representation in tables, pictographs, and bar graphs and outcomes, as applied using appropriate technology in critical thinking, problem solving, reasoning, communicating, making connections, representations, and decisions in real life.